Okay, we're going to try to find out the centroid location of this shape. It's a compound shape. It's a lot of different shapes put together. Um, how many shapes do we identify here? 3 shapes? Are you sure? 4 shapes? Are you sure? Okay, if you show me how you can do 2 shapes, because if you can do 2, I'll be really impressed. Okay. What are the 3 shapes that we have? Okay, so there's a semicircle. I'll go ahead and I'll just put that one in yellow. There's a semicircle. Okay, what else? There's a box. So, box. And I guess I gotta go ahead and like color in the rest of the stuff over here too. This is the box area. Okay, and so we're gonna make the triangle. I'm gonna put it in red like this. So the triangle that we're really referencing is right here. Let's get some dimensions for this. Um, let's say that this is 10, 5. Let's say that this diameter that goes across here is also 5. So this will be like a 10 by 10 square. Yeah, it's close enough. It does kind of look like a rectangle, doesn't it? Let's say that this one is 5. I wrote 4, but let's say that it's 5. And let's say that this side down here is 5 as well too, just to make the math easy, because I don't want the math to be like super complicated or difficult with this one. Okay, so we have 3 different shapes that we have to worry about. That means that we have how many centers of masses that we have to worry about? 3. More than 2. We have all 3. We have the center of mass of the semicircle, we have the center of mass of the square, and we have the center of mass of that triangle notch that we're going to take out of there that we have to worry about. So there are 3 center of masses that we really need to calculate first and foremost. So let's go ahead and let's break this apart into x's and y's. So we're going to have the x side and we're going to have the y side. How do we want to identify these shapes? Do you want to call them ABC, 1, 2, 3, square, semicircle, triangle? What do y'all want to call them? ABC? Okay. Let's make the semicircle A. Let's make the square B. And let's make the triangle C. So that means we're going to have an x bar of A. We're going to have an x bar of B. And we're going to have an x bar of C. Remember, these are the center of mass locations in the x direction. We're going to have a y bar A, we're going to have a y bar of B, and we're going to have a y bar C. We're going to have areas of those two. Those areas don't really change. So the area of A, the area of B, and the area of C, I'm just going to write that once, and then I'll just copy the number over on the other side. Once we have those pieces of information, we can calculate the center of mass. Where's our reference point? Where do y'all want to put it? Where? Bottom left? Okay. The way that I drew it, I think it's reasonable to put it in the bottom left. You could also do top right if you wanted to. Um, it's kind of up to you guys on how you want to do it. It is. It is very possible to have a centroid that is not on the shape. Like for example, if you have a C-beam and the beam goes like this, and there's a bunch of mass to the left and the right, it's very possible that your center of mass can be like sticking out of the beam a little bit, depending on how far out those legs go. So like the center of mass of a table is a really good example of that. If you've got really heavy legs, they're really massive, that center of mass of the table is going to be actually below the table part. The lower it is to the ground, the more stable it is. Cars are the same way. You want their center of mass to be as close to the road as possible, because if your center of mass is higher to the road, you have a higher tendency of flipping over. So yeah, let's not do that. Not on our top 10 list. I'm going to just kind of put approximate dots on where these centers of masses are. And let's go for A first, since this is the very first one. This is up at the top. So we're going to be going from this location down, and this location over. So how far up do we have to go in order to get to our center of mass of the semicircle? Close, because we're not going to cut this semicircle in half. This is 10, right? But we can't just say that this is the halfway point. We can't say that the semicircle is at a halfway point because this is the circle side, right? So the x bar for the circle is going to be a formula that should be familiar to us by now. And if we don't know it, we should know where to locate it. In your notes, in your brain, in a book, on the internet. Yeah, 4r. You got it. Okay, that's it. 4r divided by 3 pi. That's what we need to plug in to get that number. So it's 4 times 2.5 divided by 3 pi. And I don't think it's going to come out 2.5, but if it does, I apologize tremendously because that would have meant that you were correct and I just like shot you down for no reason. But I don't think it's going to be 12.5. Well, what do you mean how high is the circle? 1.06? Okay. So we're going to do 10 plus 1.06 because if we calculate that out, it comes out to be 1.06 units. So this is going to be what? 11.06 because we're adding the 10 plus the 1.06 from the semicircle. All right. X bar of b, this one should be a little bit easier. It's a length of 10 and it's a square, so I'm about to say y'all should. Yeah, it's just cut in half. It's just cut in half because it's a square. X bar of C, we are going to have to do a little bit of work on. We're going to say that this leg down here is 5, and this leg right here is 5. And we need to know how far we need to go across to get to here. And I'm going to go ahead and make the dash all the way across here. We need to go up, and we need to go across this way. So we're going to need to go up this direction. The centroid location is always from the thick side. So we're going to be going from the right left to get that distance. So from here to here, how far is that centroid location? There's a formula for that one too. So x bar c is going to be equal to 8.33. Are you going ahead and adding them both together? Okay. Do it step by step for me. So this is 1.66, right? Because it's 1/3 of the base. So 5 divided by 3 is 1.66. That means this side over here, you're right. That means this side over here is what? 2 point, or how about 3.33? Okay, so if we add the 5 and the 3.33 to get that total distance across, that total distance is going to be 8.33. I agree. I do agree. Okay. You want to do the y bars next or the areas? Okay. Area of A is a semicircle, so it's going to be the area of that circle divided by 2. So what's the area of a circle? Okay, so the area of A is going to be pi times the radius. It's not 10. It's not 5. 2.5. So we're going to do 2.5 squared, and then we're going to cut it in half. So y'all double check me. Pi times 2.5 squared divided by 2. Everybody got 9.8? Okay. 9.8 units squared. Area of B. Yeah, it was 100. Okay. Area of C. It's a square, and it's 10 times 10. 10 times 10 is 100. Area of C. 12.5? I'm going to add one thing. So I know it's 1/2 base times height, so it's 1/2 5 times 5. But I'm going to go ahead and put a negative in there. Since that's a notch that's taken out of the side, I'm going to be subtracting that area. I'm not going to be adding that area. So I'm going to go ahead and put that negative in there right now. I'm going to say that, okay, this is negative 12.5 because I know that I'm going to be taking it away. Y bar of A. Oh, crap. Hang on. I really messed up on that one. Hey, the Y is actually the direction that goes up, right? That means that this 11.06 is the Y bar, because that's what we calculated to go up here, right? Whoopsie, that was a problem. Uh, so the X bar is the direction across, which would be 2.5, yeah, which would be 2.5. It's it's Monday. It's Monday. The day just started. It's okay. The good thing is that we can double check ourselves. That's fine. YB. This is the Y going up for the square is going to be half of its height, so that's going to be 5 units. Good. And the Y bar C is going to be the height going up, which is going to be a third of 5. This is going to be the same thing, 1.66, just 5 divided by 3. All right, we have all the pieces of information that we need in order to solve this problem. One of them is a notch that's going to be taken out of the square, so one of them is going to be negative whenever we put it in there, and that's going to be okay. All right. So, does everybody have this information because it's getting ready to move? Because I'm running out of space to write. And if I write it on the board, then nobody online can see it. So I've got to move it. So we need the formula for the centroid location. So the x bar of the centroid and the y bar of the centroid is going to be equal to the sum of the areas, AI, times x bar I, divided by the sum of the areas. And the exact same thing for y bar. The only difference is that you're using the y's instead of the x's. Remember, those i's are just reference points. Oops. I tried. There we go. When you get to the bottom of the tablet, it gets a little bit tougher to do. AI. There we go. So that means we're going to need our x bar, we're going to need our areas, and we're going to need our y bars for each one. And we're going to have to run through the calculations. There are a lot of letters, but the concept is more important than the letters is. As long as you can take that formula and be like, oh, hey, I'm adding the products and then I'm dividing it by all the areas put together, then you're good to go. I'm going to take a picture of this so I can actually like remember what the numbers are because I'm about to move this and that's going to be bad. So I'm going to take a picture of this. Bloop. There we go. There. Now I've got it right there. So I'm going to scroll down and we're going to do this. Okay. So for the X bar, for the sum of the products, let's see here. Let's do this. Sum AI XI over sum of the areas. And our products on top are going to be what? Let's see here. We've got an X bar A and we've got an AA. The X bar of A is 2.5. The A of A, the area of A, is 9.8, right? Added to X bar of B times the area of B, that's going to be 5 times 100. I'm just ignoring the units at this point because I'm sorry. It makes me a terrible engineer, but whatever. I'm a fake one anyway. X bar of C times the area of C would be 8.33 times the area is negative 12.5. And we need to add all those together and get a number out of it. On the bottom, we're just adding all the areas together. So that's 9.8 for the first area of the semicircle, plus 100 is the area of the square, plus a negative 12.5 is the area of the triangle. And once we get those things, we'll have our x bar. So what I like to do is I like to take all the numbers up on top. Forget about dividing right now. Just get all the numbers on top and get them in the calculator. And then I can get a number and just simply divide the two numbers onto each other. Especially if y'all use cell phone calculators, that's going to make your life a whole lot easier. So I'm just going to do 2.5 times 9.8 plus 5 times 100 plus 8.33 times negative 12.5. And I get 420.4. So on the top, I've got 420.4. These would technically be units cubed up top because you've got an area times a length dimension. And then on the bottom, that's just going to be 9.8 plus 100 minus 12.5, which is 97.3. And then divide those two onto each other. So it's 420.375 divided by 97.3. And that comes out to be an x location of about 4.3 units. 4.32, but I think we'll just go with 4.3 since we didn't exactly have that much precision on our measurements at the very beginning. So we'll say about 4.3. Okay? And does anybody get anything different? Everybody good? All right. Maybe. There's a lot of numbers. The y bar is going to be the exact same thing. Sum of the AI times y bar I divided by the sum of the areas. Okay, so let's do the same thing. We're just going to do it with y bar. That means that structurally, your problem is going to look almost identical. The only difference is that there's going to be some numbers that are different. So your areas are still the same. It's still going to be negative 12.5. The other area is going to be 100, and the semicircle is still going to be 9.8. But our y bars are what we have to worry about now. So the y bar of A is 11.06. The y bar of B is 5. And the y bar of C is 1.66. Okay, and then on the bottom, nothing changes. So don't redo that. That bottom part is just 97.3. Okay, you can add them all back together if you want to, but you're going to get the exact same thing. So there's no need to do that. So just get the very top part, multiply it out, and then we can get our y bar answer. So 11.06 times 9.8 plus 5 times 100. Oh, I just put in 0. 5 times 100 plus 1.66 times negative 12.5. And I get 587.6 over 97.3. When we divide those, that gives us 63.18, or let's do 60, let's round up. So we're going to do 63.2 units. That cannot be right. Yeah, I bet if you did 6, you probably did better than me because it looks like I did not round that appropriately. Oh. That's because I just divided by 9.3. Hang on. I can do this. I'm good at arithmetic. 97.3. Yeah, there we go. Let's fix that. Pretend that didn't happen. So that is 6.0 units. That makes a lot more sense. So our x bar location is going to be about 4.5 or 4.3 units over, and our y bar location is going to be about 6 units to the right. So since these are both positive, we know that the 4.3 is to the right, And we know that the 6.0 is the units that go up. I think I just said that backwards, but I think I'll get the idea. Okay, and then we can go back up and look at the shape and see if that makes sense. 4.3 and 6. So if I were to look up here and go over 4.3 and up 6, that would put us about right here. So my guess wasn't too terribly far off, which is probably a good thing. Okay. It makes sense to me that the center of mass in the y direction is going to be above the 5.0 point because there's a big semicircle sticking out of the top. So that does actually make a lot of like physical sense. Okay. Y'all have any questions about this one? Comments, concerns? All right. There's a lot of numbers to process there, but we'll go ahead and we'll tackle another example. But for the recording, I think that'll just be it for today.